structure splits out as an int. Exactly. If you remember stage evaluation from a couple lectures ago, right? When we define this function runs entirely. The very reason this thing is computed is because it's a method. These things that are computed, they're just defined because it's a method.
So to really answer the question about the application, I looked it up quickly. What happened is Scalar 3 doesn't like adding a string to, sorry, a number to a string. So the types mismatch right there was causing the issue. What was allowed previously was when you see int added to a string, it converted that into a string automatically. And this feature is, according to some quick Googling, gonna go away. Instead, this is a much cleaner way. I mentioned that I did not want to use any fancy formatting thing, but now I do. So this thing is just like the F string in Python. It says, okay, this is a formatted string, so you can extract numer from the context, put a slash next to it, and then whatever the nom is. Okay, the first part is done. I want to talk about operators. Operators is basically this. When you have, let's say, a named variable, another named variable, and you kind of say, okay, I want this to interact with this in some way. For example, I want to add R together with S. Okay, this guy is known as an operator. In fact, this is a binary operator. Why is it binary? Because it has two arguments, right? R and S. Now, we have seen this idea in so many languages. We have seen that in Python, you can do something so that you can have your custom addition operator. In Java, has anyone tried? Let's try to recall something. There was this idea of big integer, right? What if I have big integer R and big integer S? How do I add them? R dot add S, and this results in a big int. Is it possible for me to teach Java that from now on I would like to be able to write R plus S? It turned out that that was not an option in Java. Another language that allows you to do something like this is C++. What I wanted to say is different languages have different means of supporting this feature. It boils down to two main camps. One is something known as operator overloading. Broadly speaking, I can think of Python in this camp. I can think of C++ in this camp. What it means is there is a preset list of operators that they allow. For example, this is allowed, this is an operator, this is an operator, so on and so forth, right? And when you want to essentially override the behavior of plus, you just need to know that, for example, in Python, you can override this function. You might remember this from 101. Or in C++, you might say operator override plus. But basically, there is a list of operators that the language already has. And you just write logic to override it. Another camp says, well, let's do something funky. And it turns out Scala is going to be in this camp. Let me show you something before I describe what it does. In here so far, we did r.add s, right? This is very standard when using the dot notation. We begin with r and we say dot add, calling the add method on r with s as a parameter. What if we relax the way the language works? Instead of insisting on that dot, what if we allow a very liberal interpretation of what function calls look like? Now, it is starting to look more like this version. R space add space s. Make sense? Okay, so that's one maneuver by relaxing what function call syntax has to look. Instead of using the conventional dot notation, you just say, okay, function calls from this point on is going to look like, well, name space the name of the method space its argument, which is what we did right here. In fact, I can continue with this idea. Add t. Good. But this is not the end of it. The approach Scala is taking is we're going to insist that operators and functions are the same. What do I mean by that? Number one, it means this. A more liberal function call syntax. Number two, what's the name of the function we're using right now? Add. What if this is a possible operator name? You see what I typed? Val star equals to 5. Yes, that's a valid identifier. In fact, or don't tell me that I showed you this. This is a valid identifier. In fact, you can start ranking people. Unicode works. I just want to say that. Meaning, if you have set up Chinese or some other kind of keyboard, you can use it here. Can you guess the next maneuver? Instead of calling this thing add, I'm going to call it this. Instead of calling this multiply, I'm going to call it this. On line 11, what is the name of my function? Plus, but not plus, just the plus symbol. That's the name of the function. Other languages don't like this. Scala loves it. So, the only two changes I made where I renamed add to the symbol plus. I renamed mult to the symbol multiply star. Okay, copy, about to paste it here. Val R rational 1/2. Val S rational 3/4. R plus S. Oh, sorry. I believe that's the way it works. I don't remember exactly, but we'll see. Yeah. R plus S. Now it works. Yeah. So the second approach is we're just saying that function and operators are the same. And we just rely on a very much liberal syntax. At this point, sky is the limit because if this is a possible operator, you could have many other fun things, right? Please do not do this on your exam. Name your variable star dash star or something. Exception. Anyhow, that's how it works. What's more fun though is this. The same old precedence rule, PEMDAS, still applies. Now you might be wondering, how does, for example, if you have got two operators, one is something that looks like this, the other one is something that looks like this. Which one comes first? Scalar documentation describes how to rank them. I don't remember that, and I don't encourage you to remember them either. Just read it if you read it. One last thing before we do another fancy example. What if I've got R and I would like to negate it? What does it mean? It means I want it to be able to say negative R. Right? How do I do that? It turns out there is a feature which is kind of a combination of magic keywords and being more liberal in terms of syntax. That feature is to use the function called unary underscore the negative sign. And in this way, we can support negative sign, unary negative. what if I just do this? It's not a binary operator. It just applies to R itself. It doesn't have another thing to work with, right? So his question was, why can't we use the negative function? All right, I'll pause and take questions about this example. Yes.
Why would we want to do
Why would we want to do what exactly?
this?
Writing weird functions and handling your own operators.
Yes, I feel like it's just going wrong confusion of what plus
So, imagine you want to write your own big int, right? Would you prefer writing r.add every single time, or do you rather have the ability to write things that are more readable, like r plus s? This might be a personal choice, and the split tends to be whether you like Java or not. There are obviously people who prefer the bloated style where you do r.add, right? And there are also people who prefer to see math expression that looks more like math expressions. I think this gives you the freedom to choose between the two ends. If you still prefer .add like that, you can. If you don't like that and you want to be able to write it more quote unquote naturally, you also can. Another answer is there are situations where people want domain-specific language so that they can write code more cleanly for their settings. This freedom lets them do that. Without having to write another compiler, which can be another kind of fun on its own. Any other questions before I attempt to do another example? Let's put this away because we want to try something else. Not long ago, we created a data type called expert or expression, and what we did was we said, okay, case class, we have constant, right? Where you take in a double and you kind of keep it there. And that's one possibility for what an expression can be. What else did we do? We have negation, and we say here's an expression. We said case class, what else? Sum, E1 expert, E2 expert, and we have prod, a product. Yeah, that's what we did long time ago. I kind of want to be fancy. In fact, I'll add one more thing. I'm going to add a variable. Var for variable. And my goal is to be able to write something like this. Let's define x to be x. Okay? But then I can say E is going to be x plus 3 times x plus 5. That's going to be ultimately what I want to be able to write. Good? Notice that I can't quite do that just yet. This is broken code. But ultimately, I want to be able to do this. If I can do this, I can record this expression in a very natural way. IDE even detects that this is a valid expression. if it is actually working. So what has to happen for me to be able to do this? It turns out it doesn't need much. If you remember what a trait is, it acts more like an interface. Except it is a fancy interface in that we can have implementations in here as well. So this is what I'm going to do. I'm going to say, if I have got an extra and I add that to another expression, this will be translated into sum of this and that. If I have star, I'm going to return prod of this and that. Good? With only these two things, I can't quite do that fancy thing just yet. For basic things such as x plus x times x, it's already working. Let's try to understand why this is working. First, we define a variable x, right? So this is nothing fancy, it is this case right here. Now, the reason this works is because x is an x curve. Whenever we call plus on x curve, this thing is called. When this thing is called, it returns sum of whatever on the left-hand side and whatever on the right-hand side. Same for x times x. Good. But we don't have to stop here. We can throw in unary this thing, where this is going to be equal to negation of whatever it is, right? And already I can do negation of x plus x times x. We can become more and more fancy with this thing. Now, I mentioned something about trait, which is this thing acts like an interface in Java. What do I exactly mean by that? I can say, I insist that all these guys have a function called eval. The goal of eval is to evaluate that expression. But I need to provide it some context. What is this context going to look like? Well, it just says, if you see a variable x, return the value which is kept in the map. So how do I expect to use eval? I might call eval with this thing. If it's a map, where inside it I say x takes on the value 2.0. This is what CTX is, context. The goal is wherever we see a variable called x, we're going to replace it with this number 2. Okay? What I'm doing so far by writing line 5 like this is I'm promising that all these guys will have this implementation, the eval method, which is why all these guys are mad, right? Well, Scala is mad at me because none of these has eval. I want to do this quickly. So, it turns out that case class can also have additional implementation. What do I say the outcome of evaluating a constant should be? Tell me the answer to this. Let me zoom in a little bit. It should be the constant, but what is that constant called? Is it called n. Notice how this n and that n links together. It's the same n. What about negation? My goal is to implement eval for negation. What do I say? Negative of this is the picture I have in mind. Negation of the thick paren. What do I say so that I know the outcome of this guy? Can I tell what the outcome of this guy is? Is there a quick way to know? Maybe you can look at E dot for inspiration. Which one caught your attention? The game plan is to determine the value of the negation of an expression. I will first evaluate the expression inside. Sorry. Context. Right? I will evaluate the outcome of the expression inside, and that is accomplished through e.eval, providing to it the context. Once I have that outcome, I negate it. Hence, this negative sign. Okay, so two steps. One, recursively evaluating the inner expression, and once we have the number, we negate it. Can you write this one quickly? Like this. The picture what you have in mind is you have two parens, you want to add them together, right? What we do is we evaluate the outcome of the first paren, and then we evaluate the outcome of the second paren. Together, now we have two numbers, both doubles, and we just add them up. I believe for prod, it should be clear that this is what we're going to do. Make sense? Which leaves us with the only thing here, variable. I claim this is what I want to do. CTX is a map, context is a map. CTX of name looks up that key in the map and returns it. For example, if it so happens that I call CTX of X with this thing, I will get 2 in return. It's just a function lookup. Right? Okay. So why do we do all these? Use your photographic memory to remember all these, right? So that we can play test it now. E of map of X 2.0. Oh, eval. What are we able to accomplish with this? We can first write the expression in a meaningful, very natural kind of way. And then somehow Scala understands it to be the actual sum of prod of sum of something. See this line right here? Without us having to type it in manually. Okay? So that's what we have been able to accomplish with this. And then we can do e.eval because we promised that eval is a thing now with map like this. And this is the outcome of evaluating that expression when plugging in x equals to 2. This last bit is optional. I'm just going to show you something fun and wonky for the heck of it. What I did was I defined an implicit function. An implicit function in this case is something kind of lurking in the background, waiting to do type conversion when necessary. Previously, I was not able to do x plus 5, but now I can. Before I wrote this function, x plus 5 was meaningless. The reason was it did not know what to do with x being an expression and 5 being a double. But by introducing an implicit function, now it looks into its repertoire of functions and it knows that if you have a double and you expect an expression, now it knows how to turn a double into an expression. So that's the use of such implicit functions. Again, this is more like for your entertainment. So now I can write expression 5 plus x times 2, I believe, and it will just work. I want to close this lecture with a philosophical discussion. Right? It's kind of the best way to end a makeup class. And the topic that we kind of want to philosophize over is the idea of decomposition. Exactly what I mean is when you have this big concept, or just a concept somehow, right? And you kind of want to break it down so that you can start programming with it. There seem to be two schools of thoughts so far in this term, at least in your career so far. One is you can go sort of the functional style. What it means is you break things up into functions. So you decompose problems of program into functions, and the functions will carry out some logic, some computation. So one is functional. We organize things around functions. The other approach, and this is what you have been taught in some of the classes, is object-oriented style. Okay. Where in object-oriented programming, what you do is you decompose problems into classes, and for each class, you give it a list of actions that it can do, and they relate among themselves somehow. Which is better? Anyone? Any proponent of functional decomposition? And you feel like this is strictly better, always. How about anyone in this camp? Object-oriented lovers? You just feel like object-oriented programming will shine every single time. Anyone? How many people think that the answer is, it depends? Everyone. The question is, what does it depend on? Anyone? What you can use it for, but exactly what attribute are we going to use to say, well, maybe we should go functional, maybe we should go object-oriented? Anyone want to try to summarize when the functional style of decomposition will be superior to object-oriented, and when object-oriented style will be superior? For some concrete things so that we can discuss over this philosophy, I like to draw for you a matrix. The column will be sort of data variance. So this column is data variance. What do I mean by that? Well, things like const, sum, prod, some other possibilities. I'm using expert as my example. Okay. So what else did we have? Variable, all those possibilities, right? All those data variants. So these are my rows. I also have the columns. The columns will be sort of the actions that can happen. What do I mean by that? I mean, maybe you want to do two strings. Maybe you want to write eval. Maybe you want to write something else. Okay? These are the actions that you insist that you can do on this thing. In general, overall, we're referring to the expression data type. Okay? One way to help think about these two frameworks is the functional programming decomposition is essentially organizing this thing by essentially columns, right? What do I mean by that? In a functional style, what you will end up writing is something like this, right? You have, let's say, eval. Eval is going to take in an expression. And, okay, it has to be below, so I can take advantage of that. So this is the functional style. And what you have is you have cases for each of the data variables. But like you have one function per action. You can have eval, which is one function, and then these are the different cases for that function. ToString is going to be another function. If you have another function, then it's going to be another function. Yes? Makes sense? Okay, so in the functional style, you have case, the different cases, right? Sum, you do something. Case prod, you do something. So code is organized around the actions. These correspond to functions. ToStrings will be another function. And again, the shape is the same. what do we do under different cases? Okay, so this is the functional decomposition style. If you think about what has to happen when you try to do this in an object-oriented manner, what do you think will have to happen? So the bottom version is going to be sort of the object-oriented style. First question, where is eval going to live? It turns out we have seen this example above. For constant something something, right? You're going to have eval equal to something. You're going to have toString equal to something. You can try to guess what sum will look like. Sum will have the same set of functions. If that makes sense. And if you think about it, prod will have the same structure. It will have what eval looks like, what toStrings looks like, right? Okay, so how can I summarize this? In the functional style, it's going to be function-centric. What we'll end up with is we're going to have one function per column, per that column. And in each function, you have branches for different data variants. What about object-oriented? You would have one subclass per row, meaning const is its own subclass, sum is its own subclass, prod is its own subclass. But the thing about this is each subclass has all the methods for the rows. Meaning const will implement toString, const will implement eval, sum will do the same, sum will implement toString, sum will implement eval. Prod will implement toString, prod will implement eval. Right? One organization is, this thing is top level. The columns are top level. The inner thing is just branches in different cases we have to handle. In the object-oriented decomposition style, the top level is these guys are going to be subclasses, they're going to be classes. And for each one of them, the inner thing will be toString is one method inside such a class. But they have to appear everywhere. Having spent quite some time talking about this, what are the pros and cons of either approach? Now, one of the reasons we have to structure code in a meaningful way is we want it to be future-proof. You want to be able to extend it in the future, right? If one day people walk into this room and they say, hey, I want a new data variant. Let's add exponential. Which one is easier to support? What has to be done? Let's take a moment, try to imagine what changes will be necessary if you have a new data variant for either case. For function, for the functional decomposition style, what has to happen? For each function that you have written in your class, dig them up, add a new case, right? That sounds like a pain. On the other hand, for the object-oriented style, you just say, here's my brand new class, implement all the functions, right? You don't actually need to touch existing code. So adding a new data variant is easy in double O style, but very painful in the functional style because it involves digging up old code, modifying them. On the other hand, what if I say, oh, add support for differentiation? What do you think will happen? For the functional style, what do you need? Write a brand new function. Do we ever need to touch existing code? No. Let's write a new function. These are the different branches. What about in the object-oriented style? You go through all the classes, dig them up, add in div to every one of them. Okay, what's the conclusion? They both suck. They are both wonderful in different ways. The moral of the story is there is no perfect answer. You kind of have to anticipate what tend to be the kind of change that will come in the future. If you can predict the future, you can choose the right approach. Failing that, well, it's up to your luck. The two techniques are orthogonal, as you can see, right? One favors adding the rows, one favors adding the column. But once you commit to one design, you kind of were stuck with it. I don't have a good answer. I wish there is. Question is, okay, question from the audience. Can we do both at the same time? Maintain both function decomposition and object-oriented decomposition? The answer is yes, you can, but then you get the worst of both settings. What does it mean to be adding a new data variant? Modify or add a new class here, easy. But then because you're maintaining both things, right? You have to modify all the functions here. Yeah. So you double the work, you double the pain. For your entertainment at home, we have 2 in-class exercises, which I will upload now. The exercises should be relatively quick. It involves adding weird named functions, and once you're done with that, it should just work. So what I will do now is I'll upload the lecture. There it is. Yep. Upload it. Yeah, that's it for today's lecture. I'll take questions. Without further questions, you can also talk to me in person or run away or start working on it in class activities.
Our next class is tomorrow, right? In the usual classroom. Out of curiosity, do you like this room more or downstairs more? This one? How so?
The tables.
The tables are nicer? Being able to plug in?
More space as well.
Alright. The sad thing is in the morning, this room is fully booked. Not just this room, actually all the computer labs. I'll walk around and chat with people who are still here. It's okay. Linux has technically has this mascot. It's not exactly the Linux mascot, but close enough. Yes. Magic. Yeah, black magic. So before when I say x plus 2, for example, you try it at home, right? Before we type in this line, you get an error because it doesn't know how to add an expression to a double. Right? Because we so far we only taught it that if you see an expression and the right hand side is another expression, it will return the sum of whatever on the left hand side and the right hand side. So if you say x plus 2, on the left hand side is an expression, on the right hand side is a double. It doesn't know how to convert that double into an expression. This function says, okay, I don't know where you're going to live, but you are going to live lurking in the background of Scala. Whenever someone demands that a double be converted into an expression, please use it. Okay, it's kind of a lonely class. Did you have to do things with the exact same signature? I don't think it's well defined either. So basically, you're supposed to only import it or define implicit functions that you really want to have in that context. Otherwise, well, one of them is going to be called. I don't know which.
I might have missed it.
I talked about it briefly last time. I'll write a summary and send it in this form later tonight or tomorrow. Yeah, I think people kind of expect that that message.
Okay, thank you.
Sure. But basically, in class, paper-based exam, and then we have another part, exam part 2, which is going to be take-home programming, if that makes sense. So next week, Thursday, for 2 hours, we're going to be sitting in some room, working on the exam on a piece of paper, close book, close notes, that kind of thing. Well, yeah. And then you'll go home, and you have another set of exam, which you're going to be working on for a day, roughly speaking. And during that time, it's open book, open notes.
Okay.
We're going to be writing code.
So
Yeah.
the final exam, how's that going to look like? The final exam?
The final exam, we will not have a final exam during the final exam slot.
Okay.
We're going to have the same format in week 12.
Okay.
Meaning one of those days, we're going to have like an in-class exam, and then separately a take-home exam.
Okay, that makes sense.
The final exam slot will be poster session for the projects.
Okay. Thank you.
Yes. And what is this thing doing? Still recording?